Let's solve this system of three linear equations containing three unknowns by elimination. So let's eliminate x in equations 1 and 2. To do this, we'll multiply equation 2 by -1 and add it to equation 1. So we will have x minus 2y plus 3z is equal to 1. And our new equation 2 will be -x minus y plus 3z is equal to -7. And let's add these two together, and we will get -3y plus 6z is equal to -6. And let's call this equation 4. Now, so we just eliminated the variable x in the first two equations. Now let's eliminate x in equation 3 and also in equation 2. So let's multiply equation 2 by a -3 and add it to equation 3. So that'll give us -3x minus 3y plus 9z is equal to -21. And equation 3 remains 3x minus 4y plus 5z is equal to 7. And if I add these two together, what I'm going to get is -7y plus 14z is equal to -14. And let's call this equation 5. Now, if we combine equation 5 with equation 4, we'll have a system of two equations with two unknowns. So let's rewrite that. I'll have -3y plus 6z is equal to -6. That's our equation 4. We'll combine that with our equation 5. -7y plus 14z is equal to -14. Now, there's our system of two equations and two unknowns. Now let's eliminate one of the variables in this system. And we can do that by multiplying equation 4 by 7 and equation 5 by a -3. And what that'll give us is -21y plus 42z is equal to -42. And when I multiply equation 5 now by -3, I'll get positive 21y minus 42z is equal to positive 42. And if I add these two equations together now, what I get is 0 is equal to 0. And since I have 0 equals 0, which is a true statement, that means that this system has infinitely many solutions. And to find those infinitely many solutions, what I need to do now is go back to one of my equations, and I'll go back to equation 4, and I'll solve it for y. So let me write equation 4, which is -3y plus 6z is equal to -6. And let's solve this for y. So I'm going to subtract 6z from both sides. And that'll give me -3y is equal to -6z minus 6. And I'll divide both sides by -3. This gives me y is equal to 2z plus 2. That tells us right there what y is equal to in terms of z. Now let's take what y is equal to and substitute that into equation 2 to figure out what x is in terms of z. So what we'll have is x plus my y, which is 2z plus 2 minus 3z equals 7. And let's solve this for x. So let's combine our like terms, and it'll give us x minus z plus 2 is equal to 7. And now let's subtract 2 from both sides and get x minus z is equal to 5, and add z to both sides and get x is equal to z plus 5. Now, we know what x is in terms of z, we know what y is in terms of z, and z is going to be any real number. So to write our solution, we'll write it in set notation like this. It's going to be the set of all ordered triples x, y, z such that x is equal to z plus 5, y is equal to 2z plus 2, and z is a real number, any real number. And that is the solution of this system.